Okay, I'm sorry if this was a little clunky of a switch between two videos. I don't even know what was going on, just things weren't appearing appropriately on Photoshop. Things were just like disappearing. So then I just stopped recording thinking that maybe I was wasting too many resources. That wasn't the issue. So I'm going to pick up where we were, which was fine where I ended the video. Is pretty much just getting into scalar multiplication. So again, addition and subtraction, as long as the matrices have the same order, all you need to do is add or subtract each entry one by one. So I'd start in the top left, add the top left if I was adding, or if I was subtracting, I would start in the top left and subtract the top left. So aij plus bij for all I and j if you're adding, or aij minus bij if you're subtracting two matrices. Scalar multiplication is also easily defined. There's no crazy trick to this. It's straightforward. I need to switch to this one. There are 3 lines in this equal sign when there should not be. So for scalar multiplication, so when c is a constant, we just multiply each entry by the constant. So in this case, I have 2 times a, so I'm just going to have 2 times, let me make this a little bit thicker. This will be 2 times 1 for 1, 1. For 1, 2, it'll be 2 times 2. That's for row 2, column 2. For row 1, sorry, for row 1, column 2. Row 2, column 1 is going to be 2 times 3. Row 2, column 2 is going to be 2 times 4. So this is just equal to 2, 4, 6, 8. So again, scalars, order doesn't even matter in scalar because you only ever have one matrix. All you are doing is multiplying each entry by your constant. Now I'm going to save us a little bit of time. Division itself does not exist for matrix operations. This is not defined, so we cannot divide matrices by matrices. I personally don't even like to say we can divide a matrix by a scalar. We can. We could do a divided by 2 because a scalar is just a constant, and really this is the same as a half times a matrix. And we know scalar multiplication is defined. But division by a matrix is not defined. So the only operation we have left is matrix multiplication, which can be a little bit odd. So before we even look at examples, I'm going to re-emphasize the importance of order. So when I'm given 2 matrices, say A, B, I always write out their order. So if I had a 3 by 2 times a 3 by 2, I physically write this out every time I do one of these problems. We cannot multiply 2 matrices if this inside number for both of them, so I have 2 numbers kind of on the outside and 2 numbers on the inside. If these are different, then multiplication is not defined. So we cannot do this. This answer does not exist. If I do have the same number, so if I had a 2 by 2 times a 2 by 2, well, I look at the inside numbers. They are the same, so we're good. my new matrix is going to take the order of the first outside number by the second outside number. So this product, if A was a 2 by 2 and B was a 2 by 2, would yield a 2 by 2 matrix. Now from here, we have to actually test a property, and we're going to see something interesting, I guess. I think it's interesting. If we're checking if AB is the same as BA. And we're going to look at two simple matrices for also doing the problems. So A is going to be 1, 3, and B is going to be, so this is a 1 by 2 matrix. B is going to be a 2 by 1 matrix of 2, 5. Now I'm going to have A times B. I'm going to call it C. And I'm going to have D as B times A. So the first thing I always do is write out the order. So A is a 1 by 2. B is a 2 by 1. The inside numbers are the same, so this will in fact have an answer. And the order is going to be a 1 by 1. B times A, well, B is a 2 by 1 matrix, and A is a 1 by 2 matrix. So the inside numbers are the same, but our resulting matrix, D, is actually going to be a 2 by 2. So we're now already seeing that A times B is not necessarily going to be the same thing as B times A. It may not even have the same order. In this case, A times B is a 1 by 1, and B times A gives me a 2 by 2. Now, how we actually go about doing these is a bit of it's an algorithmic and a recursive process. We go, whatever our first matrix is, we do each row at a time. And then whatever our second matrix is, we do each column at a time. So we always do rows. And then while we're doing a row, we do each column. So in case of A, what I need to do is take the sum of each product for each entry. So if I'm looking at row 1 and column 1, the first entry for this row is a 1, the first entry for this column is a 2, so I'm going to do 1 times 2. I'm doing a sum of each product. So this is going to be the sum of 1 times 2 and 3 times 5, plus 3 times 5. So A times B is equal, or C is equal to 1 times 2, which is 2, plus 3 times 5, which is 15. So C is the matrix with single entry 17. For B, for D I should say, we're going to have, I'm going to look at each row one at a time, and then while I'm doing each row, I'll look at each column. So I have 2 in row 1. I have 1 in column 1. So this is just 2 by 1. I don't have any more numbers in my row, so I can move on to the next column. So in row 1, column 2 of D, I'm going to have 2 times 3. I now finished every column in A. I'll move to the next row. So I'm going to row 2 of matrix B. So that's going to be 5, column 1 again. So I'm in row 2, column 1. So this is 5 times 1. This is going to be 5. And then I go to column 2. So I'm in row 2, column 2. 5 times 3. So D is going to equal 2, 6, 5, 15. So, as we saw, AB does not always equal BA when dealing with matrix multiplication. Usually it actually won't. We're going to be doing more examples of matrix multiplication tomorrow, and probably even going forward after that, just going to keep doing a bunch of practice with it. This is probably one of the more important pieces of information you need to know about matrices. We're going to do just one more small example for today. That was too large. These can get very out of control once you get to even a 3x3 matrix. So we're going to stick to just a 2x2. So I have A as a 2x2. I have B as a 2x2. So the inside numbers are the same. So I can in fact multiply them. And I'm going to end with a 2x2 matrix. Alright, so now we're going to go, again, one row at a time. While we're working with a row, we do each column. We are getting the sum of the product of each entry. So I'm starting with row 1. I'm actually make a new layer, and then I can make little arrows. I'm going to make this in green. So row 1, and so if you weren't in class, you're actually getting a little bit of benefit with this. If you were in class and you haven't watched this video, I'm going to do this tomorrow. That way we're not chipping anybody out. Call this one C, or column, and call this guy row. Okay, that way I can slide things. That would be helpful. So I'm looking at, right now, row 1 from A. I'm always working with the rows in A and the columns in B. So rows are my first matrix, columns are my second matrix. So since I'm dealing with row 1, column 1, I'm entering into, in my answer, row 1, column 1. I'll have 1 times 4. Remember, we're doing the summation, so this will be plus 2 times 0. Oops, not 20, 2 times 0. So I've finished all the entries in column 1. There's only 2 entries in column 1. And I have 2 products. So I'm now going to switch to column 2. So in this case, I'm still working with the same row. So I have 1 times 5 plus 2 times 1. I've now finished every entry in column 2. I have no more columns left. So the column is going to go back to 1. And the row, we're now going to look at row 2. So now I have row 2, column 1 in my answer matrix. It's probably not the official term, but that's what I'm calling it. So we have 3, since that's entry 1, and entry 1 of the column is 4, so I have 3 times 4, plus entry 2 is 4, entry 2 is 0, 4 times 0. That finishes the column. So we move the column to column 2. So now I'm in row 2, column 2. So I have 3 times 5. We're doing the summation, so plus 4 times 1. I've finished everything in the column. I've finished everything in the row. I'm out of rows. I've constructed my 2x2 matrix. All that's left to do is solve. So I have 1 times 4 is 4, plus 2 times 0 is 0. 1 times 5 is 5, plus 2 times 1 is 2. 3 times 4 is 12, plus 0, and then 15 plus 4. So I will have 4, 7, 12, 19. Tomorrow I will post some practices. I'm going to post a more formal write-up for or how to really multiply matrices, kind of in an algorithmic way. And I'm also going to have a couple examples, and then we're going to try and finish 8.4.